Okay, we're going to do today the derivatives of the inverse trigonometric functions, okay? So just I want to quickly review the concept of inverse function, okay? So you can see here on the screen, the paper, the parabola. I have the function f of x equals x squared. Everybody knows that this is the graph for that function. And then, well, remember what you did in algebra 1 and algebra 2 to find the inverse of this function. So you took simply, this is y equals x squared. Then you change the y by x and the x by y, so y equals y squared. And then you solve for y, correct? That's what you did. So y equals x squared is this parabola right here. Then you interchange the variables, and then you solve for y, you get the inverse. Okay, in this case, when you solve the inverse, right, well, yeah, when you do the change, what you are doing really is this one. So this is the y, this is the x, you see? And then when you change the y by x and the x by y, you get this new graph. You change the y by x, the x by y, and then you see this new line. Technically, this is the inverse, but this is not a function. So usually what we do is we suppress one of the branches, right? Since the beginning, we suppress this branch. We just take, for instance, the positives, and then we flip, and then we get the inverse function of the square root function. In this case, algebraically, you know what happened. You know what happened is when you solve for y, you have, okay, the square root of x is the square root of y squared. These two cancel, so you have y equals, but remember that the square root has two different solutions, the positive and the negative, because you square both, you get a positive. So this is why you select one of the branches. Usually we get a positive, so get the square root of x, correct? So for the trigonometric functions, right? Yeah, the same happened with any other function. For instance, this is x cubed plus 1, and then you get the inverse just switching y by x, x by y, the graph of the inverse. For instance, for sine, this is the graph of the function sine x. Okay, well, if we follow the same procedure, change the y by x and the x by y, we are going to flip this thing. This is, okay, this is technically the graph of the inverse, but this is not a function because you intersect with the vertical line many times the sine. So what we do is very simple. We restrict the domain of the function. So we put like two cardboards right here from negative pi over 2 to pi over 2. So this section is going to be our new function, new sine function. And then when we flip this thing, we get just this portion right here. And this is pretty much the graph of the inverse function of the sine. It's a very short graph, goes from negative pi over 2 to pi over 2, and from 1 to negative 1. The same is going to happen with the cosine, correct? The cosine is right here. This is the graph of the cosine. So if you flip, if you switch the axis, you see again the same problem. So in this case, what we do is, well, from 0 to pi, that is going to be the fraction we're going to take from the graph. And then when we flip the graph, we see the graph of the inverse coming from the restricted domain. So this is the graph of the cosine from negative pi over 2, from negative 1 to 1, and then from 0 to pi, correct? Tangent and cotangent were the same, right? So this is the graph of the tangent, not upside down. This is the graph of the tangent. And then if we flip, we see the new graph. So the only thing we have to do is, okay, because the tangent graph is several branches, what we have to do only is remove all the branches and keep this one, right? From negative pi over 2 to pi over 2, and then from negative infinity to positive infinity. So this is the point. The inverses of a differentiable function, because this is differentiable, because this is soft, so the tangent line exists at any point, right? The inverses are also differentiable, so you have tangents along this line. So this is what we are going to find today. So we're going to find the inverses of the trigonometric function. So it's going to be very simple. I'm not going to go on and obtain the formulas, the specific formulas. So we are only going to work with the formulas, okay? So when we have, for instance, this is f of x equals sine x, this is the trigonometric sine function, the inverse function f negative 1 of x is going to be the arc sine of x. So this is the sine, this is the inverse. For the cosine, we're going to have f negative 1 of x, the arc cosine of x. Usually in the textbooks, they denote this one as sine negative 1 of x, and this as cosine negative 1 of x. So you have to get used to this notation also, but usually in this course, we're going to use the arc cosine and the arc sine, correct? So sometimes this is confusing because you think that this is the reciprocal of the x, because negative 1 is a negative exponent, so this is the reciprocal. So that's why I don't like to use too much this one. So usually I keep this notation, so the arc sine, correct? All the trigonometric function, for instance, the tangent, okay, the inverse is going to be the arctangent of x. And everything is going to be the same, correct? The inverse of cotangent is the arcotangent, the inverse of the secant is the arcsecant, and so on. So this is the important part. When you take the derivative respect x of the arc sine of x, this is going to be the result. So if this is your variable x, my derivative is going to have this strange shape, 1 minus x squared. There is a way to get this one, but I don't want to bore you because this is more for the classroom than for the online thing. So we're going to accept this one, right? The same, the derivative respect x of the arc cosine is going to be the same thing, except that you are going to have a negative 1 at the top. 1 minus x squared. The derivative of the tangent, the arctangent, right, of x is going to be 1 over 1 plus u squared, and the derivative of the arcotangent is going to be the same formula, but with the negative, 1 plus u squared. The other two functions, the secant and the cosecant, the arcsecant of x is going to be kind of weird. So, but it's going to be 1, then we're going to have here x, and then the square root of x squared minus 1. And the derivative of the arcosecant is going to be the negative of this previous, is x square root of x squared minus 1. So there is a way to get these formulas, but well, I don't want to make this class too long. So we're going to accept these formulas. Obviously, if you remember your formula booklet, they are here at the back, all of them. So let me just share the screen right here. You can see here in your formula booklet at the back, all the derivatives we have been doing. The derivative of the constant, the derivative of the x, the derivative of the power, the derivative of the trigonometric functions, the derivative of the exponentials, and these are the new derivatives. So when we have the arc sine compound with a function of x, in this case u, you are going to put only here u prime, the derivative of u. In every one of them is the same formulas I wrote here on the little board, but they are going to have a u prime. So it's a good idea if you have this formula chart next to you for the practice, okay? So these are our formulas now, right? We are going,
Ramírez,
yes.
si es U en la fórmula, ¿por qué poniste 1? Why you put 1
Bueno,
on the
what is the derivative of x?
Oh, 1.
1.
Oh, okay.
All these ones are the derivative of x. So if you have here a function of u, then you have here u prime, correct? Now let me show you again the screen. You see? It's the same. If this is x, the derivative of x is 1, and this is x squared. If this is x squared, then you're going to have here 2x, and then here x squared. So it's pretty much the same. So there is usually I obtain these formulas in class to make you simpler to understand why, but well, at this moment we have less classes, right? So we have to go faster and skip some things. So don't worry to copy these ones. Remember, you have your formula booklet. They are here, okay? And then we're going to do the next class, these ones, right? The integrals, so the reverse of this. Okay, now, any question? Let's just go and solve some problems. I have here the assignment. You see here the assignment. Okay, let me just again. Here is the assignment. So you see the assignment right here. So this is the assignment I posted in the Google Classroom. So I'm going to have here, so y equals x times the arctangent of x, correct? Well, so let me just stop the share. I'm going to see this formula, so y equals x times the arctangent of x. So this is the product of two functions. So I have to do the formula for the product. So remember your formulas here. This is the formula right here. Here is the formula for the product. The derivative of the product is the first function times the derivative of the second one plus the second one times the derivative of the first one. So this is what I'm going to do. And also, because I have an arctangent, I'm going to use this formula right here. Okay, so here is this one, x equals the arctangent of x. So I'm going to do my calculus. So y prime is derivative of this. Okay, the derivative of the x is 1. 1 times arctangent, I'm going to have arctangent x. Plus the derivative plus x times the derivative of the arctangent. So I have to check my formulas. What is the derivative of the arctangent? Well, 1 plus u squared, x squared in this case. I put u plus x squared. Let me just correct this one. This is x, right? So, but in the case we're going to have a u, so this is going to be 1 times 1 plus x squared. So I'm going to use this because this is the tangent. So the derivative of the arctangent is 1 plus 1 over 1 plus x squared. So this is my answer. Let's see another problem. Just change screen. I have a little bit more complex problem. So I have y equals the x times the arcsine of the exponential function, the natural exponential function. So this is what I have. This times this. So again, I'm going to do the product. So y prime is going to be the derivative of the x. Well, that's a 1. 1 times the arcsine of e to the x plus this x times the derivative of the arc sine. Okay, let me see, what is the derivative of the arc sine? Well, just remember this. Let me change this by u's. U, this is u prime, u square, right? So this is the formula. So the derivative of the arc sine is 1 over 1 minus u squared, so this argument squared, times the derivative of the argument. So this is going to be line square root 1 minus ex squared, so ex squared, times the derivative of e to the x. Well, you remember the derivative of the exponential is the exponential again. And that is going to be my answer, correct? So the derivatives are pretty simple. Questions at this point? Pretty much fine. Remember, derivatives are simple. The only you have to do is remember the formulas. Remember, the formulas are right here on your formula booklet, right? Yeah. In your formula booklet, you have all the formulas we're going to use. Remember, if you have addition, product, quotient, or the inverse function in this case, and if you have the chain rule, well, you have all these formulas, correct, are with the chain rule. So you have a function of u inside the cosine. Well, this is the sine. This is the derivative. Same here. So keep these formulas next to you. The idea is in some moment you memorize them so you don't need a formula booklet. Okay? Well, let's see. Let's solve another problem. So I have, let me see what problem I have. I have problem C, right? So I have these two. This is, oh my gosh. Well, I have y equals the arc sine of x to the -1. Okay. So let me just go to my board. So this is the arc sine of x to the -1. And I have to remember what is the derivative of the arc sine. So derivative respect x of the arc sine of u is u prime over square root of 1 minus u squared. Okay, now I just identify what I have to find. This is the u. So it's not very difficult to find the derivative. So the derivative is y prime equals, well, I put my line, 1 minus u squared. So is 1 square root of 1 minus x to the -1 squared, right? And then the derivative of x to the -1. So I have to remember that this is a power, so it's going to be -1 times x to the -2. Correct? Now, do we have to keep this one? Well, yes, because you get negative exponents, you see? You get negative exponents right here. Yeah. So you have to keep the negative exponents. So the only maybe you have to do is a little algebra. So this is negative x to the -2, right? A square root 1 minus, then this square is the product of these two numbers. So this is x to the -2. And that's your answer. So we don't have to do positive exponent because we receive negative exponents, so I don't have to worry about it. If they give me 1 over x, yeah, I have to worry because this has to be in terms of 1 over x, and that simplification is going to be kind of long algebraically. Correct? No questions here? Okay, let me just go next problem, right? So the next problem is going to be y equals the arc tangent of x over 1 minus x squared. Yeah, this is going to be terrible. Let me just really use the whole board for this one. Yep. So this is going to be Okay, so this is y equals the arctangent of x over 1 minus x squared. Okay, I just erase this part. And now it's okay, what is, I need y prime. Y prime equals. Okay, so that's what I have to find. So what is the derivative of the arctangent? So d dx of the arctangent of u is u prime over 1 plus u squared. That is the derivative, the formula for the arctangent, right? Okay, well, if you apply this directly, this is not a problem. Y prime equals, well, is 1 plus u squared. So is 1 plus this expression squared. So you have 1 plus parentheses x over 1 minus x squared, everything squared, correct? Square, everything square. Much better, okay? Now, and then we have x over 1 minus x squared prime. So technically this is the derivative, but of course you cannot do only this. So we have to do this derivative. Okay, now this is going to be a little painful. So I'm going to put a line here. So what is the derivative of this quotient? Well, remember the derivative of a quotient. Denominator square, okay. 1 minus x squared square. Then denominator 1 minus x squared times the derivative of the top. The derivative of the x is 1 minus the top, x, times the derivative of the bottom. Okay, derivative of the 1 is 0, derivative of the x squared is 2x, so it's going to be negative 2x over 1 plus x over 1 minus x squared, every square, like this one, correct? This is okay. Well, now the calculus is over. Obviously, this expression looks weird, but we're going to simplify a little bit. So I'm going to do some algebra. So I'm going to take this top, and it's going to be 1 minus x squared times 1 minus 2x squared over 1 minus x squared over 1 plus x over 1 minus x squared. Everything squared, correct? Okay, now at the top of this expression, I can put here negative 2x squared minus, in this case is plus, really, because negative times a negative is positive. So I'm going to have 2 minus 1, 1. So I'm going to have 1 plus x squared over 1 minus x squared over, 1 plus, and here I'm going to do something. So I'm going to split the square, so x squared over 1 minus x squared, correct? 1 plus. So what I'm doing my algebra. Because I have a quotient square, I square the numerator and I square the denominator is what I did here. Then, okay, algebra continues. I'm going to mix these two. So I'm going to put 1 plus x squared over 1 minus x squared over, I'm going to put this one right here. So I'm going to put here 1 minus x squared plus x squared over 1 minus x squared. Yeah, this problem is weird. Then I'm going to apply my sandwich rule. These two at the top, the product, and these two at the bottom. So I'm going to have 1 plus x squared times 1 minus x squared over 1 minus x squared, parentheses, 1 minus x squared plus x squared. Yeah, crazy. Not bad, because you see this expression is repeated right here, so I can cancel this with this. And then I'm going to have 1 plus x squared over 1 minus x squared plus x squared. And that is my answer. Yeah, crazy, right? So if you see, the derivative was not really difficult. You apply the formula, this is your expression. Then to get the derivative of this, well, is this one. But the next part is try to simplify this expression, and then you have to do all this boring algebra to get something like this. It's possible to simplify this one more. I don't think so, because you are going to have, possibly you expand this one, you can combine on x squared from 1x squared here, but no more really, correct? So this is pretty fine. Okay, so again, our most annoying part in these problems is the algebra. Okay, so all the problems are going to be pretty much the same, the application of the formula, and the algebra is going to depend on what functions we have to work with. In this case, we got a quotient. That was this so annoying. Okay, let me see. Let me just put this one right here. Let me see the next problem, right? So the next problem in the practice here in the notes, well, it's pretty much the same kind. So I'm not going to do all these things. So you see the problem is 1 plus x or 1 minus x. So it's going to be pretty much the same annoying thing. Let me just try something much better, like the arcotangent of the square root. Okay, so I'm going to erase this portion. And I'm going to put right here y equals the arc cotangent of the square root of x minus 1. And I want y prime. So what is the derivative of this function? So, okay. Let's recall what is the derivative of the arc cotangent. So the derivative respect x of the arc cotangent of u, when u is a function of x, is u prime negative over, and this is going to be without the square root, is 1 plus u squared, correct? So this is my formula, so I have to use the formula right here. So I'm going to put, okay, y prime is line, so it's going to be a square root of x minus 1 prime, so I have to get the derivative of the thing, 1 plus a square root of x minus 1 square. So I just plug in this u inside this formula, and then I get something. Let me see now. What happened at the bottom? Okay, a square root and the square cancels out. So I have, before I perform the numerator derivative prime, I'm going to see 1 plus x minus 1, correct? So because the square root and the square cancels, I have x minus 1, and these two ones are going to cancel. So I'm going to have 1 over x times the derivative of x minus 1 square root. Now this derivative is going to be a power. Remember, x minus 1 square root is x minus 1 to the 1/2. So this is going to be 1 over x times 1/2 x minus 1 to the negative 1/2 times the derivative of the inner part by the chain rule. The derivative of the x is 1, the derivative of the 1 is 0. So this is my derivative. So using some algebra, right? This is going to be 1 over 2x times 1 over the square root of x minus 1. Why this one? Because this is a negative exponent, so this expression is going to be in the denominator, and the 1/2 represents the square root, so it's going to have 1 over square root of x minus 1. That's my expression. Obviously, I have here a negative, always a negative, always a negative. I have to drag, and this is going to have a negative at the front because the formula right here. So the derivatives are not that difficult, right? Are pretty much simple. Okay, let's do one more to finish today, and I just give you the practice. The practice is pretty much the same thing. It's not that difficult. And well, I have y equals the arc cosine of the square root of x. Well, let me just go to the side. Okay, what is the derivative of the arc cosine? D dx of the arc cosine of u is the u prime negative over the square root of 1 minus u squared. Okay, so this is my formula. So I'm going to apply my formula. So y prime is line negative the derivative of the square root, so square root of x prime, and here I'm going to have 1 minus the square root of x squared. So I apply my formula. Now I have to do my last calculus part, but let me just simplify this one. This is 1 minus the square root of the square is the square root and the square cancel, so I'm going to have 1 over the square root of 1 minus x, simply, times, well, I'm going to put here a -1, just -1, and then the derivative of the square root. This is x to the 1/2, so this is going to be 1/2 x to the -1/2. And then the only I have to do is, well, I'm going to do some algebra. This is the square root in the denominator, so it's going to be -1 over 2, this 2 is in the denominator, the square root of x times the square root of 1 minus x. Right? This is this portion right here. This is the -1. So this is my answer. Okay. So everybody catch the idea? It's not very difficult. It's just the application of the formulas. What you have to do, try to memorize the formulas. Remember, these are the general rules when you have combinations of functions. And these are the derivatives using the chain rule. So by this time, you have to memorize or be very familiar with these formulas and keep this with you always if you don't want to memorize them. So keep this with you, next to you. Okay, any question? John Fellows?
No.
Okay. I'm thinking to do another class on Thursday. Is fine for you? Thursday at 10 or tomorrow? What do you want?
Thursday at 10.
Thursday? Yeah?
Yeah.
Because, well, I can do daily class, but yeah, I know it's too much. But Thursday, I'm going to do integration. So possibly I have to do Thursday and Friday. You don't want class on Friday, we have to do them Wednesday and Thursday. So we have Wednesday, Thursday, Thursday, Friday. What do you want?
Wednesday, Thursday.
Wednesday,
Thursday,
Thursday,
Luis?
yeah.
You prefer to do the Friday off, but the Friday there is no way out, so we don't have place to go.
Wednesday, Thursday.
Yeah, I'll just work.
So the situation is all the days look the same, right? You don't feel what is a Sunday, what is a Friday, what is a Thursday. I don't know. With this quarantine, we're in this way. So you vote Wednesday, Thursday, or Thursday, Friday?
Wednesday, Thursday.
Wednesday, Thursday.
Para tener el viernes libre todavía.
Yvonne?
Wednesday, Thursday.
Okay, well, Wednesday, Thursday then. Tomorrow at 10 and Thursday at 10, correct? Okay, so the homework is on Google Classroom. Okay, let me just share that one. So it's right here. You see on the screen the homework? Okay, so you have here a product. Here you have the derivative of this plus the derivative of this, then the ln, so you have to use the derivative of the ln and then the arctangent. Here you have a product with a power. So pretty much the same thing, correct? And then here, you have, again, implicit differentiation. So you have to do the derivative of this portion, correct? But tomorrow I want you to go to the first 2 pages, and if you have any question tomorrow, I can go to this problem. So don't overload. Try to go this 8 regular, and tomorrow I explain this. Okie dokie.